Hi, and in today's episode, we're going to take a little exploration of the asset manager and how Lyra is using the asset manager to manage the various game experiences that it ships with, as well as some of our own work with the asset manager in our persistent inventory layer. So, this will be a good section around just understanding the asset manager, what it's there for, how to use it, and some of the challenges we're having working with it to get it to function properly. So all right. So let's talk first about the primary components of the asset manager. Um, we commonly refer to it as the asset manager, but in fact, it's really the asset manager and the asset registry. The asset manager is the singleton class that you see in your settings when you pull up your project settings. It's responsible for basically managing the asset registry. It will allow you to add and remove items from the asset registry. It handles all the startup functions when you initiate the engine. And so you can think of the asset manager as authoritative over the asset registry, and then the asset registry being sort of the current state of the assets in your project or world. And so I kind of think of them in that regard. They're most frequently referred to as the asset manager. But if you do look at the blueprint nodes that come with the editor, many of them are asset registry oriented blueprint nodes. In fact, the asset manager itself is not exposed to blueprints, only the asset registry is. So that's the sort of interface that you work with. The second half of the project is around this notion of a primary asset and a secondary assets. And so quickly, the primary asset is what the asset manager controls, and you can request it to load a primary asset. When you load a primary asset, it will load any secondary assets associated with the primary asset. The easiest example of that is, let's say you have a static mesh as a primary asset. That static mesh has a material and likely textures associated with it. Those are secondary assets. They will also be loaded into memory when you load the primary asset. The most common primary asset in the default primary asset is the actual level. So when you package or cook a project, what the editor is doing is it's grabbing the primary assets. By default, that's the level. And then it is recursing itself through that primary asset and packaging up all the secondary assets. So if you have a level, in that level, you have a bunch of actors. Those actors will all be secondary assets to the primary asset of the level. You may have a bunch of meshes in that world. Your rocks, your trees, your buildings, those are all secondary assets. So when you load a primary asset, know that all the secondary assets are being loaded as well. And so let's talk about how you might identify or become a primary asset. As I said, the level is the default primary asset. It's called UWorld, also synonymous with level. But there's two primary ways to make any of your blueprints or C++ classes a primary asset. The first is to inherit from primary data asset. And this is probably the most common approach taken throughout Lyra, is that many of the experiences are in fact inheriting from primary data asset. And as you can see from the inheritance structure, anything that's a U object could then be further subclass to be a data asset, and then further subclass to be a primary data asset. And what becoming a primary data asset gives you over a simple U object is all the hooks into the asset manager. So the easiest and fastest way would be to just create your parent relationship to a U data asset. In fact, that is what we did with our Lyra inventory item definitions. When we jump in, we'll show you that's the path we took. The second path is, in some cases, you can't change your parent hierarchy to include the primary asset. in those cases, so think of an actor, maybe your character actor, which has a default inheritance from a actor to a pawn to a character to your character. You don't want to go in and change that inheritance structure. Instead, you're able to get the get primary asset ID and override that function. So every U object, which is the fundamental root of all of Unreal, everything eventually starts from a U object that works its way up, has this function called get primary asset ID. Now that function is not exposed to Blueprint, so it is a C++ function, but you can basically override that get primary asset ID and set your actors to have their own primary asset IDs. As we said, these are the two primary methods. If you look at the signature in the white block of the get primary asset ID, that's what you would put in your C++ file to override your actors. And then you'll notice the two code blocks that I've copied in below, the Lyra experience definition and the Lyra user facing experience definition. They both inherit from the U primary data asset. All right, so with that basic fundamentals, let's jump into the editor. So let's look at the project settings for the asset manager to get a little more understanding of how that is configured and set up. So in our project, under Edit, Project Settings, under Game, you'll see Asset Manager. So if you click on Asset Manager, you have an array of primary asset types to scan. And the primary asset type is 1/2 of the primary asset ID. So any primary asset ID is its type. So in this case, map, followed by a colon, followed by its name. And we'll talk a little bit more about that in a minute. But basically, in the primary assets to scan, so when the asset manager launches, it will read these entries. It will parse through this list of arrays. And for each entry it finds in here, it will generate primary assets for this definition. So it will scan through looking for a primary asset type it's going to call map. It will look for anything with a base class of UWorld. And so if UWorld has children, they will also be marked as maps. You tell it which directory or directories it can scan in. So this will scan the game's maps folder for any UWorld objects. And you can specify specific U objects, in this case UWorlds, that you want to add in. So either it's in this folder or it's one of these two. They're all going to get added automatically. And what you'll notice is that for Lyra, the Lyra game data, the game feature data, the experience, the user-facing experience, the lobbies, the action sets, and then this is the one we've added. They're all defined in the asset manager in your project settings. And that's important because they have to be defined here in order for them to work in your plugin data sets. Right? So when you add folders in your plugins, the names need to match. And so, for example, if I were to have Lyra experience definition here, and I'm scanning for anything that has a base class of Lyra experience definition, I'm allowed to look for blueprint classes. By default, I scan the game system experience. Then when you look at a game feature, so if I open a game feature, let's open a game feature. This game feature then has an asset manager section to it where we add more primary asset types to scan. So here you see the map and world. Basically, we're adding another directory entry for the asset manager to scan. Here you see the Lyra experience definition, and we're adding another directory for it to scan. So each of the game feature data, which are tied to a game feature, have the ability to inject more locations for primary asset types. So that's the linkage between the asset manager, which has a default set of things that it's scanning, typically in the project folder. And then for each game feature, we can inject new folders for it to scan as well. So let's look at some of the functions that you can use in Blueprint to access the asset registry. So first to note is you can always do the get asset registry node, and then off of that perform a variety of context sensitive actions. So there's a whole list of things that you can do right off the asset registry. There are two sort of conversion sets, whether you have your class and you want the primary asset, or you have the primary asset and you want the class. These two will convert back and forth between the two, as well as the object back and forth between a primary asset and an object. You have a variety of asynchronous loading functions. These are functions that will load without blocking the game thread. So you have 3 of those that you can use and reference. You have 2 unloads, where you can unload either a list of primary assets or an individual primary asset. And there's this notion of bundles, where you can bundle together a variety of assets and then change the various states of each of those. I'm not using these. However, they're something you could explore. You have the get primary asset list, where you can provide one of your primary asset names, which were defined in the project settings, and then get a list of primary assets that match that asset type. Of course, you have your break and your make for the struct, because the primary asset ID is largely just a struct, and then a is it loaded flag that you can use to test and check. So to sort of demonstrate some of these, go to this very simple on begin play. We'll wait for 10 seconds, and then we'll get our item definitions, loop through that array, printing each of the primary asset names on screen, and then end it with an end list. So to see that happen, let's launch. Log in. And then when we launch the world, that actor, I just placed the actor in the world. So after about 10 seconds, we should see a list scroll across the screen. And there they are. So you can see that get the output log here. You can see that the structure is the type, a colon, and then the short name of the class or the object. So each of those in our content drawer would be items, resources. They match these names. And you'll note that the way we're loading those into the asset registry is these are all defined off of the Lyra inventory item definition, which if I pull up the C++ definition of that, we changed the definition to be of a primary data asset type. So in standard Lyra, the inventory item definition is a U object, no different than the fragment. But by switching it to a U primary data asset, we have access to manipulating within game the inventory definitions via the primary data asset. That brings us to our use of the asset manager in our persistent inventory system, where there's two cases. One, when we're writing data to the database, we need to write it in a format that we can later retrieve and convert back into an object. So we're using the asset manager for that. So when we store our inventory to our database, we basically loop through all the items that we have in inventory. We convert that into from a item instance into a primary data asset. And then using the primary data asset to string function, we convert that into a string which we store into the database. And upon startup, we do the opposite. We get the items from the database, and we then, find it here, right here. We then take the string that came from the database, convert that into a primary asset ID, and then use that primary asset ID to get the item definition class. And that's what we use to instantiate our new item. We wrote a helper function here that takes that asset ID, checks that the asset manager is up and running, and then simply does the get primary asset object. And this is a template. So we pass it the template that we want it to come back as. We give it the primary asset ID, and we get back a T subclass of our inventory item definition. And so that's how we've coded it. Now let's see how that works in action. So back in game, when we log in, launch the world, we're going to go ahead and let's let all that stuff finish. We basically have no inventory. We go over here, we pick up these building recipes on building stuff. Pick up the crafting recipes. Oops, I hit the table. Put the material. And let's put the gems in storage. We're going to stop there. If we look at our database, we refresh our database, we copy our inventory field, take a look in the notepad, paste that. You'll see that each of the items that I picked up have been recorded as their primary asset type and their primary asset name. And then my stack counts, the polished gems are a stack of 25 and are in storage. The metal ingots is a stack of 50, but it's on my character. And so if I were to go back into game, log back in, launch a new session, it will now read from the database and perform the reverse action. And so if I were to open my inventory window, I have my equipment, my crafting, my blueprints, my 50 stacks here. I go to storage. I have my gems in storage. So on changes, we write to the database using the asset manager primary asset ID. And on reading, we take that primary asset ID out of the database, convert it into an item instance or an item definition, and then create a new item instance in our inventory. So that's a bit of how we're using the asset manager. Hopefully that's helpful.